how many of you can answer this question correctly? If you have taken Calc 2 and if you have a letter grade A, I think you are a good candidate to try this question. Even though this question looks very simple, it seems like taking quite a long time for people to get the correct answer. For example, recently I posted this question on Facebook, where I have over 500 people with bachelor's degrees in mathematics or engineering, and I have at least 100 people with master's degrees in one of those two fields, and also there are some people, at least 20 to 30 people with PhDs in mathematics or engineering areas, and many of them tried this question, and I'm not saying that they are always practicing these kinds of integrals, but after doing a PhD or after doing a master's degree or after doing a bachelor's degree at least, mathematics is quite a practical thing for most of those people. And still those people also took quite a long time, and I got several responses after about 3 days of trying, and the shortest answer, the best answer I would say, also had 3 big pages. So even though this question looks simple, it seems like a challenging question, and whenever I post this question for my students, it seems like they also struggle almost always. And before trying this question correctly, I mean before getting the answer for this question, they almost always come to me to get help. So if you're a math guy, I would like to challenge you to try this question. If you would like to try this question, pause the video now and try this question yourself and see if you can get the answer. If you can get the answer like within 20 minutes or 30 minutes, you are a genius. All right, now I'm going to start solving this problem. To solve this problem, what I'm going to do first is I'm going to multiply both top and bottom by x minus 3 within the square root. So I have x minus 5 on top and x minus 3 in the bottom, and I'm going to multiply both top and bottom by another x minus 3, all inside the square root. Now the square root is actually gone from the bottom, and it is x minus 3, and the numerator is inside square root. You will have x squared minus 8x plus 15 dx. Now what I'm going to do is I will rewrite this question using x minus 4. That means the denominator I will write as x minus 4 plus 1, and the numerator I will write it as x minus 4 everything squared, and if I do so I will have a plus 16. I need to subtract 1 dx. Alright, now what? I'm going to take a substitution at this point. So the substitution I'm taking is x minus 4 equals secant theta. That means my dx will be equal to, the derivative of secant theta is secant theta tan theta d theta. All right, and then I'm going to use that substitution in place of x in this question. So I have integral inside the square root. X minus 4 squared is a secant squared theta minus 1. In the bottom, x minus 4 plus 1, which is secant theta plus 1, and I have a dx which is equal to secant theta tan theta d theta. Okay, now what? Secant squared theta minus 1 can be written as tan theta, tan squared theta of course, and that tan squared theta is inside the square root, so it will get out of the square root as tan theta, and I have another secant theta and I have another tan theta, which becomes tan squared theta on the numerator. In the bottom I will have secant theta plus 1 outside d theta. I hope this step is clear. Here I have used the identity 1 plus tan squared theta is equal to secant squared theta. From that we have secant squared theta minus 1 is equal to tan squared theta. Alright, and then it is inside the square root, so it will get out of the square root as tan theta, first order tan theta, and there's another tan theta right here. They will be simplified to a tan squared theta. So what I'm going to do next is I'm going to write this tan squared theta using the same identity one more time. That tan squared theta can be written as secant squared theta minus 1. Now we are almost done with this question. Tan squared theta will be replaced as secant squared theta minus 1, and outside there is one more secant theta term. In the bottom I have a secant theta plus 1 and d theta. So what's next? I'm going to use the difference of squares. A squared minus b squared, we know this is equal to a minus b times a plus b. I can apply that identity for this part, secant squared theta minus 1, where a equals secant theta and b equals 1. So I can write secant squared theta minus 1 as secant theta minus 1 times secant theta plus 1, and outside I have a secant theta term, all divided by secant theta plus 1, and outside there's a d theta. Now you can see that secant theta plus 1 and secant theta plus 1 can be cancelled. Alright, the rest is very straightforward. Now I can distribute that secant theta, so the integral becomes secant theta times secant theta is secant squared theta minus secant theta d theta. Now it's very easy. Integration secant squared theta d theta minus integration secant theta d theta. We know secant squared theta is from the standard table. If you integrate secant squared theta, your answer is tan theta minus integration of secant theta. Integration of secant theta is equal to natural logarithm secant theta plus tan theta, and there will be a plus c as well. But remember, theta is a variable that we introduced, so we have to go back and replace that theta with x. Here we used this substitution. X minus 4 was equal to secant theta. If x minus 4 is equal to secant theta, what should be tan theta? Tan theta is the square root of secant squared theta minus 1. Secant theta is equal to x minus 4. So x minus 4 squared minus 1 should be equal to tan theta. That minus ln secant theta was x minus 4 plus tan theta once again is x minus 4 everything squared minus 1. And there is a plus c outside. Well, of course, we can simplify these things a little bit more. Inside this first square root, I can simplify that as x squared minus 8x plus 16 minus 1 becomes a plus 15. Minus ln absolute value x minus 4 plus, once again inside of this square root I will have x squared minus 8x plus 15 plus c. Alright, I hope you enjoyed this question. Thank you.